This is an app walkthrough for WhenToWater. It gives a California homeowner one simple instruction: water this tomato plant 4 days this week for about 49 seconds each day. It looks simple. It isn't. An honest answer requires location data, plant science, irrigation formulas, recent environmental conditions, and the measured output of the homeowner's actual hose flow rate. Most homeowners don't have an irrigation controller or professional training. They're standing outside, hose in one hand, wondering when to turn the water off. Irrigation controllers calculate schedules for installed systems. WhenToWater brings that intelligence to someone holding an ordinary hose, without the cost and complexity of installing a professional system. In-app, I'll select a vegetable garden, tomato, and hose. Hose time can't be calculated accurately from generic estimates. The homeowner will fill a known container 3 times while timing each trial. WhenToWater validates the test, calculates gallons per minute, and saves the result. I'll reuse the 1.5 gallon per minute test result from my real garden test. Zip code 92243 is mapped locally to a microclimate, California's CIMIS Evapotranspiration Zone 18. The app combines typical root area of one tomato plant, basic soil context, and the homeowner's recent watering and rain observations. It works without a cloud account, API key, backend, or runtime internet connection. Behind this button, the engine converts historical reference evapotranspiration into the tomato's water demand, converts inches over square feet into gallons, and converts those gallons to the measured hose rate into time. The homeowner only sees what matters: water 4 days this week for about 49 seconds each day. The complexity is hidden, but it isn't a black box. It preserves CIMIS data, ETO, crop coefficient, watered area, hose flow, confidence, limitations, and source provenance. It's a behavioral test fixture. Plant demand, gallons, and hose duration are calculated deterministically rather than hard-coded. I use Codex and the ChatGPT desktop app to coordinate the repo, GitHub pull request, Xcode, and simulator workflow. Across those increments, 5.6 translated my irrigation domain decisions into SwiftUI, local scientific data, provider-neutral recommendation engine, persistence, provenance, and error handling. The final build passes 29 deterministic tests covering calculation accuracy, source integrity, hose persistence, recent condition overrides, error behavior, and repeatability. WhenToWater does the complicated work so the homeowner doesn't have to. They just need to know when to turn off the hose. Build Week helped me move from researching how it could work to actually building, testing, and reviewing it as a solo product developer. I had a lot of fun.